Hey guys, we're now looking at 1D.3. I can calculate the volume of composite figures by identifying the basic shapes to apply the correct formula. Okay, so this is our last set of notes for this first unit. We are almost done with KC1. So the first thing to know is, what is a composite figure? Okay. It is a figure made up of two or more what we call our basic figures. And the basic figures are the ones we learned in KC1. Not KC1, 1D1. Okay, cylinder, cone, prism, all of those are basic figures. Basic figures. Either by combining them, where we use addition, or taking one out of the other. Already stuck there. And the easiest way to think about this taking one out of the other, I think, is like a pipe. If I draw a pipe, really bad draw, right? But it has this hole in the middle of it. So the outside is a cylinder, and then I drill this hole, which is another cylinder, out of the middle of it. Okay, so I would subtract my smaller cylinder from my larger cylinder to get the volume of this pipe, because it's does not include the volume of that middle part. Okay, so that's why we subtract if we're taking one out of the other. So let's look at some examples. So here we have to decide what our two shapes are. So our first shape here is a cone. We have a cone, and we have a cylinder. Okay? So for our cone, we'll start with the volume of that. Volume, remember, equals 1/3 pi r squared times height. My radius is 3. My height of just this part is 4. I can type all this in my calculator. I would get, I believe, 12 pi. Double check that on your calculator. All right, 3 squared is 9 times 4 is 36, divided by 3 is 12. Yes, 12 pi. Okay, now I need to find the volume of my cylinder. Volume just equals pi r squared times height. So my radius is the same, right, as the cone. It's 3, and my height is this 8.5. And that gives me 72, I believe 76.5 pi. Yeah, that sounds about right. And that again is centimeters cubed. Okay. And the last thing I need to do is find the total volume. So then, to find the total, you have to think if you're going to add or subtract. This and this, they're stacked on top of each other. I'm just combining one. This isn't inside that one or anything. So I'm doing 12 pi plus 76.5 pi. These both have a pi in them, so my answer will have a pi. 12 plus 76.5 is 88.5 pi centimeters cubed. Okay. All right, looking at example 2. Again, we have to think about our different shapes. A cylindrical tube is removed from a prism. How much volume of the prism is left? Round your answer to the nearest hundredth. Okay, so my outside shape is a prism. It's a slanted prism, but remember Cavalari's principle tells us that it does not matter. And then my inside shape here is a cylinder. So we're going to start by finding the volume of the prism. So prism. Volume equals length times width times height. So I have 25 times 30 times 25. That I can't so much do in my head. 25 times 30 times 25 is 18,750. Centimeters cubed. Okay. Now for our cylinder, especially when you're taking something out, we have to be careful because you might have like these hidden measurements. Gosh, there's so many bells going on. So again, volume equals pi r squared times height. So the first thing is this whole thing is 8. So for my radius, we're only looking at half of that, right? Right, that. Okay, but we are only looking at half of it, which is 4. Okay, so I have pi times 4 squared times our height. So now, again, remember what we talked about at the cylinders. The part that connects the two is the height. Now, I have no measurement here, so we have to think about what other measurements in our picture match that measurement. It's going from this side all the way to the back side. If you notice, this line, this 30 line, also goes from the front all the way to the back. So this is also going to be 30. Okay? So you sometimes have to pull those measurements from other places. So I have 4 squared times 30. Which is 480 pi centimeters cubed. Now for our total, I have to decide, am I adding or am I subtracting? Here I'm taking the cylinder out of the prism. So the prism is bigger, so I'm going to start with that. And I'm going to subtract now, these don't both have a pi. And it tells me to round to the nearest hundredth. So this is the only time that you actually have to type pi in your calculator. Okay. So I'm doing 18,750. Minus 480 pi. If you're using my calculator, there's a pi if you see right next to H here, pi is here on this menu. It's the first one. If you're using a little calculator, there's usually a button with a pi on it. Please use that button, not 3.14. All right. That's not right. Oh yeah, that is right. Sorry. Why didn't it give me any decimals? That's okay. Okay, this calculator is rounding weird, and that's fine. So I get 17,242 pi, or not pi, centimeters cubed. Okay, so we typed pi in our calculator, so we don't put it in our answer. Just 17,242 centimeters cubed. All right, let's look at our problems on the back. Example 3, what is the approximate volume of the lunchbox shown below? So we have to, again, think about our shapes here. Here, if you look, if I continued this, it would be a cylinder, but it's cut right down the middle. So this is actually half a cylinder. And then this, right, is just our basic box, so it is a prism. So let's start with our cylinder, right? Volume equals pi r squared times height. My r here is 3. Right, that is our radius. It's only half of the circle. My height, again, if I connect it to the two sides, it'd be the same as connecting those two sides, is 10. So that gives us 90 pi inches cubed. So half of my volume would equal half of 90 pi, which is 45 pi inches cubed. Okay. Then our volume for the prism. Volume equals length times width times height. 10 times 6 times 6, which equals 360 inches cubed. Now for our total, am I combining these or am I taking one out of the other? I am combining these. So I have 45 pi plus 360. Okay. Again, I only have one pi, so I'm typing pi into my calculator. It's also telling me to round. What is it? 45 pi plus 360. It's telling me to round to the nearest inch, so I'm going to round to 501. Inches cubed. Okay. All right, looking at the last example we're going to look at in this video, example 4, does not have a picture for us. Tanya uses a cube-shaped bead with side lengths measuring 12 millimeters. Each bead has a circular hole in the middle. The diameter of the circular hole is 2 millimeters. Find the volume of the bead. So here's my beautifully drawn cube-shaped bead, okay, and it has 12 millimeters, and then it has this circular hole with the diameter of 2. Okay? So we're going to start with the volume of the cube, which is just a prism. Again, the only thing that makes it feel special about a cube, just like a square, it has all the same measurements. Okay, so of that cube, volume still equals length times width times height, which is 12 times 12 times 12. I don't know what that is off the top of my head. 12 times 12 times 12, 1,728. And this is in millimeters cubed. Then we have our circular holes, which if I drill all the way through, create a cylinder. Okay. Our volume for a cylinder is pi r squared times height. Our radius, again, our diameter is 2, so our radius is half of that, so it's 1. Our height is the same as front and back, just the same here, so our height is 12. This is kind of easy. Pi 1 squared is 1 times 12 is 12 pi millimeters cubed. So then for our total, are we adding or subtracting? We should be subtracting here. So I take 1,728, the bigger number, and subtract 12 pi. There's only 1 pi, so I have to type that in my calculator. 12 pi. And I get 1,690.3 millimeters cubed. Alright, and that's it. Example 5 will be on an extra problem video, but otherwise, go ahead and you are done. I will see you guys tomorrow.